All right, homework 27. We are doing half angle identities. And so you need to know what your half angle identities are. Over here on my notes, I have the half angle identities. Also, if you go to Alex and in the dictionary type in half angle, it will bring up the identities. You can print those out. First one, sine of u over 2 has plus or minus the square root of 1 minus the cosine of u over 2. The plus or minus depends on which quadrant you're in. Sine is positive in quadrant 1 and 2, would be negative in quadrant 3 and 4. Cosine of u over 2 is plus or minus the square root of 1 plus the cosine of u over 2. Again, depending on which quadrant you're in. In quadrant 1 and quadrant 4, the cosine is positive. And then you have the tangent. You'll notice for the tangent you have 3 different formulas. Shouldn't matter which one you use, you just pick which one you like better. I don't like the one with the square root, so I usually use one of the other 2. But keep that list handy to keep for reference. Other thing you're going to have is your list of what sine, cosine, and tangent of your main angles are, because we're going to use those values and substitute them into our formula. So you'll want to have your sheet of paper that has those angles. Again, I'm just going to put them on my paper because when I flip back and forth between the screens, it erases my board. So keep those 2 pieces of paper handy for reference as we go through these. First one, we are using the half angle formula to find the exact value of the sine of 112.5. First thing we want to do is figure out what quadrant that's in. 112.5 is between 90 and 180. So we know we're in quadrant 2. We know that our sine is going to be positive when we're in quadrant 2. The other thing we would do then is figure out what twice this is so that we can use our double angle formula. So if I take 112.5 times 2 and you multiply that out, you get 225 degrees. So we are going to do the sine of 225 degrees over 2, which is our 112.5. We know it's going to be positive because we're in quadrant 2, and our formula says that we're going to do the square root of 1 minus the cosine of our 225 degrees over 2. And so then we're going to go and look back at our paper for the cosine of 225 degrees. So if you look back at your page, the cosine of 225 is negative square root of 2 over 2. So we are going to substitute in. We're going to have 1 minus negative square root of 2 over 2 over 2. And we have a nice big mess that we're going to go ahead and simplify. So first of all, since I have minus a negative, I can make that a positive. If I go ahead and find my I'm just going to go ahead and multiply by 2. So if I multiply everything by 2, I can get rid of that fraction there. I'm going to have 2, that's going to be plus the square root of 2, and then 2 times 2 is 4. That's all underneath the square root. Since the square root of 4 is a perfect square, I can simplify that. So I'm going to have 2 plus the square root of 2, still under the square root, but then on the bottom, I'm just going to have a plain old 2 since I did the square root of 4. And that's going to be my answer, as simplified as I can do it. So the next one is going to be sort of similar, but this time it's in radian measures instead of degrees, but basically we're going to do the same thing. So I want to find the exact value of 7 pi over 8. So if I think about 7 pi over 8, my board decides to pop my stuff back up here. I want to think about what quadrant that they're in. Again, if you're not real sure, because you're not real familiar with radian measures, you might convert that into degrees. If I have 7 pi over 8 and I multiply by 180 over pi, I can cancel those out. Let's see, if I reduce this down, that would be 4, that would be 90, then I can go to 2 and 45. That's probably about all I can do. And I'm going to grab my calculator. 7 times 45 divided by 2 is 157.5 degrees. All that work just to figure out what quadrant I was in. So 157.5 would be in quadrant 2 again, quadrant 2, and I know that I'm going to have a sign that is positive. So very similar to what we had before. Again, I'm going to use my double angle or my half angle formula, but I have to double that. So if I take 7 pi over 8 times 2, that would cancel, and I'm going to use 7 pi over 4 then. So I'm going to take the sine of 7 pi over 4 divided by 2, which would be your 7 pi over 8. And using my half angle formula, it's going to be positive because I'm in quadrant 2. I'm going to have 1 minus the cosine of 7 pi over 4 over 2 then. And then, of course, our sheet with all our list on has the radian measures. If I look for the cosine of 7 pi over 4, this time I have a positive 2, or positive square root of 2 over 2. So I am going to have the square root of 1 minus square root of 2 over 2 all over 2. Again, when I simplify that, since I want to get rid of this fraction, I'm going to multiply everything times 2. That's probably the quickest and the easiest thing for me to do. And so I'm going to have the square root of 2 minus the square root of 2. Those cancel out over 4. And again, since the 4 is a perfect square on the bottom, I can simplify that a little bit more and have the square root of 2 minus the square root of 2 all over my 2. And that's going to be my answer then. The next one says use the half angle formula to find the exact value of the tangent of 157.5. Hey, that was the angle we did before, but this time we're going to do the tangent. So we know we're in quadrant 2. In quadrant 2, we would do the tangent opposite over adjacent, so a positive over a negative, going to give me a negative. Actually, on the tangent, we really don't need to figure that out because we have those 3 different formulas, but it's a good way to double check your answer. You know your answer should end up being negative. Again, I'm going to go ahead and double that. 157.5 times 2. I'm going to do it on my calculator, is 315 degrees. So we're going to do the tangent of 315 degrees over 2, and then we're going to pick one of our formulas. I decided that I would use the one that was the sine of 315 over 1 plus the cosine of 315. If you remember, you had 3 different formulas you could use for the tangent. That's the one I picked out to use. So I have to look at both the sine of 315 and the cosine of 315. So again, back to my reference sheet. 315, my sine is negative square root of 2 over 2. And then 1 minus my cosine is a positive square root of 2 over 2. And I'm going to simplify that. Again, since I've got those fractions in there, I'm going to get rid of the fractions by multiplying everything times 2. So I can cancel my fractions. I'm going to get negative square root of 2 over 2 minus the square root of 2. Oh, I messed up there. That was supposed to be a plus. I knew something didn't look right. So I should have 2 plus the square root of 2 there. And on this one, there's a negative on top. It doesn't matter if you put it on top, or you could put it out in front if you want to. So you could have negative square root of 2 over 2 plus the square root of 2, and that would be the same answer. I'd probably just leave it on top, but you know how Alex likes to say, you're correct, however, they like the negative out in front, so in best form, probably better to put it out in front. All right, my half angle identities problem type 2. On your half angle identities problem type 2, you're just going to need the sheet with your half angle formulas, and so you'll want to keep those handy that we had before. Sine of u over 2 is plus or minus 1 minus the cosine of u over 2. For cosine, we have a plus in there. For tangent, we've got a bunch of different formulas. I'll usually just use that first, or not the first one, the one without the square root, the sine of u, and 1 plus cosine of u. So, hopping back over here. We are first of all going to do our reference triangle. It says that the tangent of theta is equal to negative 15/8 and is between 270 and 360. So that angle is going to be over here in quadrant 4. This is the opposite over the adjacent. My opposite side would be negative 15 since it's going down. My adjacent side is 8. I'm then going to use my Pythagorean theorem to figure out what my hypotenuse is. So negative 15 squared is 225, 8 squared is 64, so I get 289, square root of 289 is 17, so my hypotenuse is 17. Now when I'm doing my half angles, I want to figure out what quadrant my half angle is in so I know if my cosine or my sine is going to be positive or negative. So here my half angle would be half of those between 135 and 180. So my half angles are going to be in quadrant 2. So using my half angle formula, for the cosine, my half angle formula, I'm in quadrant 2. My cosine is going to be negative. And I am going to use 1 plus the cosine over 2. My cosine, the adjacent over the hypotenuse, is 8/17. So I have 1 plus 8/17 over 2. I want to simplify that. Since I have that fraction, I'm going to multiply everything times 17. So I'm going to get 17. That cancels out. Plus 8 over 34. So I get negative the square root of 25/34. Square root of 25 is 5, so I'm just going to have minus 5 over the square root of 34. You can rationalize the denominator on that if you want. They will also take the answer in this form. If you do rationalize the denominator, you would just multiply by the square root of 34. So I'd have negative 5 square root of 34 over 34. And that answer would also be a good answer. For tangent, on tangent you don't have to worry about the sine because the sine should come out right using your formula. For tangent you have 3 different formulas to choose from. I like to use the one with the sine of theta over 1 plus the cosine of theta. And so my sine, opposite over hypotenuse, negative 15/17. 1 plus my cosine, 8/17. And again, I'll get rid of those fractions by multiplying by 17. Cancel that out. I get negative 15 on top. Then I get 17 plus 8 on the bottom. So negative 15 over 25. I can reduce that fraction down because I can divide by 5. So negative 3 over 5 is going to be my answer in simplest form. Number 5, we are between 0 and pi over 2. So pi over 2 would be 180 over 2, 90 degrees. Between 0 and 90 would put us in quadrant 1. My sine, which is my opposite over my hypotenuse, is going to be 3 and the square root of 13, if I can write square root of 13. And again, we've got to find our missing side, so if I use my Pythagorean theorem, 3 squared plus b squared equals the square root of 13 squared. So this would be 9, this would be 13. If I subtract my 9, 13 minus 9 is 4, square root of 4 is going to give me 2. So I've got my reference triangle. I want to do my half angles. Since this is between 0 and 90, I would be between 0 and 45. So I'm still going to be in quadrant 1. In quadrant 1, your cosine and your tangent both should be positive, because everything is positive in quadrant 1. So again, I'm just going to go back to my formula. So for my cosine, I'm going to do positive square root of 1 plus the cosine over 2. And so I'm going to have square root of 1 plus my cosine would be my adjacent over my hypotenuse, so 2 over the square root of 13 over 2. Lovely. I got to get rid of that fraction, so I'm going to multiply by the square root of 13. So I'm going to get square root of the square root of 13, that cancels, plus 2 over 2 square root of 13. Can't do much else with that. I'm just going to put in that big, ugly, crazy looking answer. Then I'm going to do my tangent. For the tangent, I like the sine of theta over 1 plus the cosine of theta. You can use a different one of the formulas if you want. That's just the one I like to use. So my sine would be 3 over the square root of 13. 1 plus my cosine is 2 over the square root of 13. Again, I'm going to multiply by the square root of 13 so that I can get rid of those fractions within my fractions. And so on top I get 3. On the bottom I'm going to get the square root of 13 plus 2. And again, they're not going to worry about rationalizing the denominator or anything like that. So 3 over the square root of 13 plus 2 is just how I would leave it, and I wouldn't worry about multiplying by the conjugate to simplify it any further than that. So number 6 tells us that the cosecant of theta equals negative 13/5, and you're between 270 and 360. So I'm going to be in quadrant 4. My cosecant is my hypotenuse over my opposite. So my hypotenuse is always positive, it's going to be 13. My opposite is negative 5. And if I use my Pythagorean theorem, negative 5 squared plus b squared equals 13 squared. That's 25, that's 169. If I subtract my 25, I get 144. Square root of 144 is 12. That's going in the positive direction, so I've got my reference triangle drawn. Here I'm doing my half angle, so half of 270 would be 135, is less than theta, which is less than half of 360, which is 180, puts me in quadrant 2. In quadrant 2, my sine is going to end up being positive. My tangent, although I don't have to worry about, is going to end up being negative. So on my sine, I am using plus the square root of 1 minus the cosine over 2. So I'm going to have 1 minus my cosine is 12/13 over 2. I am going to multiply by my 13 to get rid of my fraction. So I am going to get the square root of 13 minus 12 over 26. 13 minus 12 would give me 1 over 26. The square root of 1 is 1. So I would have 1 over the square root of 26. Should take it that way, or if you rationalize the denominator, you're going to have the square root of 26 over 26 for your answer. Tangent. I'm going to smush tangent in here. I always end up doing that. Tangent of theta, we said, was the sine of theta over 1 plus the cosine of theta. So my sine is going to be negative 5/13. 1 plus my cosine, which is 12/13. And then again, I'm going to multiply by that 13 to get rid of the fractions. Cancels that out, cancels that out. On top, we just get the negative 5. On the bottom, we're going to get 13 plus 12, which is going to be 25. I'm going to go over here. So I have negative 5 over 25. And if I have negative 5 over 25, I can reduce it down. So negative 1/5 is going to be my answer for the tangent of theta. Actually, the tangent of theta over 2 when we solve that. All right, 7, 8, and 9 are product to sum and sum to product identities. Again, either if you go to the LX notes and bring up their formulas under the resources, you can go to the dictionary, type into product to sum or sum to product. It's going to give you the different identities. We have 2 different sets. These ones are the products to sum, so if I have sine of u, cosine of v equals 1/2 sine of u plus b plus sine of u minus b, and so forth. And then if you go down a little ways, you'll have the ones where you go from sum to product. So the sine of x plus y equals 2 sine of x plus y over 2 cosine of x minus y over 2. Excuse me. So again, keep your notes handy or the resources off of Alex with those formulas on there, your identities. I'm not going to switch back and forth because it erases the board, so I'll just look at my notes here as we go. So first one back over here. Oh, other thing we're probably going to need is, nope, I don't have them on these note sheets, the table where you have what's the cosine of all your regular angles and what's your sine of your regular angles. We've used them a lot already. And so your sheet here that has your angles and the sine, cosine, we won't need the tangent and whatever, but we'll need the sine and cosine of your reference angles. So you'll want to have that sheet handy also. So, back to our homework page. We're going to do the sine of 37.5 times the sine of 7.5. So I'm doing the sine times the sine. If I look at my formula, it is negative 1/2, and then I'm going to have the cosine of a plus b. So I'm going to take my 37.5 plus my 7.5, and then I'm going to have minus the cosine of a minus b, 37.5 minus 7.5. So I have negative 1/2 the cosine of, if I add 37.5 and 7.5, I get 45, minus the cosine of 37.5 minus 7.5 would be the cosine of 30. So looking up on my chart, cosine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. And I have to multiply that by negative 1/2. And so I'm going to have negative 1/2 times square root of 2 minus square root of 3 all over 2. Sneaking that in there. And then when I multiply that out, just going to put a 4 on the bottom. The negative is going to be out in front of your fraction there. Or I can distribute it. So if I have negative square root of 2 plus the square root of 3 over 4. That looks a little weird in that order. Square root of 3 minus the square root of 2 over 4 also would be a better way to write your answer instead of putting the negative in front of, or in the front. And so either way should be correct as long as you make sure you get the negative on the top of the fraction with the 2 and not out in front of the whole entire fraction. The sine of 105 minus the sine of 15. So here we're doing the sine minus the sine. We're looking at the second group of formulas we have where we change it to a product. So it's going to be 2 cosine of 105 plus 15 over 2. And then we have the sine of 105 minus 15 over 2. So if I add 105 and 15, I would get 120 over 2, which is 60. If I do 105 minus 15, I get 90 over 2, which is 45. So I have 2 times the cosine of 60 times the sine of 45. I'm just going to write it over here. The cosine of 60, if I look that up on my reference paper, cosine of 60 is 1/2. The sine of 45 is square root of 2 over 2. And so if I multiply that out, those are going to cancel. I'm just going to end up with the square root of 2 over 2 for my answer in simplified form. So just a matter of plugging them into your formulas, looking up your reference angles, and simplifying from there. The next one, we have sine of 52.5, cosine of 7.5. So you want to look for your formula where you take the sine times the cosine. If I look that up, I'm going to have 1/2 sine of 52.5 plus 7.5. And then I'm going to have plus the sine of 52.5 minus 7.5. So 1/2, 52.5 plus 7.5 would be 60. And then 52.5 minus 7.5 would be 45. So 1/2, the sine of 60, if I look that up, is the square root of 3 over 2. The sine of 45 is the square root of 2 over 2. So I have 1/2 times square root of 3 plus square root of 2 over 2. Multiplying that out, then I end up with square root of 3 plus square root of 2 over 4. Didn't have the negative on that one to worry about. Second part of that, we're taking the cosine plus the cosine. So if you look at your sum formulas for cosine plus cosine, it tells us we're going to do the 2 times the cosine of 75 plus 15 times the cosine, oops, over 2, I better put that in there, cosine of 75 minus 15 over 2. All those have that over 2. So 75 plus 15 would give me 90. 75 minus 15 is going to give me 60. So I'm going to have 2 times the cosine of 90 divided by 2 is 45. 60 divided by 2 is 30. Again, I'm going to move over here. Cosine of 45, square root of 2 over 2. Both the sine and the cosine of 45 are square root of 2 over 2, if you remember that one. And then the cosine of 30, excuse me, cosine of 30 is square root of 3 over 2. On this one pair of 2's cancel out. Square root of 2 times the square root of 3 is square root of 6 over 2. I can't simplify that any further since this is under a square root and that is not. So be careful when you type that in. Hit the fraction button first, type the square root of 6 on top and the 2 underneath. If you hit the square root button first, it'll put the whole fraction underneath your square root sign and you don't want the entire fraction under the square root. You just want the 6 under the square root. And number 9 will be the same kind of thing once I get over there. This one they have in radian measures, but that's okay. I don't like radian measures, but we can work with those. Cosine times the cosine. So you want to look up the formula when you have cosine times the cosine. Tells us we're going to have 1/2 cosine of 7 pi over 24 plus pi over 24. And then we're going to have plus the cosine of 7 pi over 24 minus pi over 24. So 1/2 the cosine. This would give me 8 pi over 24. 8/24 would be 1/3, so pi over 3. This would be 6 pi over 24. 6 over 24 would be 1/4, so pi over 4. And so we're going to look up the cosine of pi over 3. Cosine of pi over 3 is 1/2. And the cosine of pi over 4. Cosine of pi over 4 is square root of 2 over 2. Oops, supposed to be a plus sign in there. I think something didn't look right. So, I'm going to have 1/2 times cosine of pi over 3 is 1/2 plus the cosine of pi over 4, which is square root of 2 over 2. So I'm going to have 1/2 times 1 plus square root of 2 over 2. Multiplying that out, we get 1 plus square root of 2 over 4. And that's going to be our answer. And the second part of that, we have a sine plus a sine. So if I look up my formula, I'm going to have 2 sine of 5 pi over 12 plus pi over 12, all divided by 2. And then cosine of 5 pi over 12 minus pi over 12, again divided by 2. So radian measures, we got to mess with those fractions in there. So 5/12 plus 1/12 would be 6/12, or 6 pi over 12. Since it's divided by 2, I can multiply by the reciprocal. So I would get 6 over 24. 6 over 24 reduces down to pi over 4. So 2 sine of pi over 4. Here I would do 5/12 minus 1/12, which is 4/12. Again, multiplying by 1/2 gives me 4 over 24. And that reduces down to pi over 6. So I have 2 sine of pi over 4, cosine of pi over 6. Looking up my reference angles, the sine of pi over 4 is square root of 2 over 2. And the cosine of pi over 6 is square root of 3 over 2. That cancels that out. Square root of 2 times the square root of 3 would be the square root of 6 over 2. And again, I can't simplify that. That's just going to be my answer. (10, 11, and 12), still using the product to sum and sum to product identities. Again, you'll want to have that sheet handy. First of all, we have the product to sum, where we have the sine times the cosine, or cosine times cosine. Fill in our formula. Otherwise, we'll have the adding and subtracting ones, where we have the sine plus the sine, or the cosine minus the cosine. Filling that into those. So make sure, again, keep those formulas handy. Product to sum, sum to product, because we're going to have to use those. So going back over here, if I go to number 10, it says use a product to sum formula to rewrite sine of d cosine of 2d as a sum or a difference. So we have the sine times the cosine. If we look up our formula, it's 1/2 the sine of 4D plus 2D, A plus B, plus the sine of 4D minus 2D. And then we're just going to simplify that. So we have 1/2. 4D plus 2D would be 6D, plus the sine 4D minus 2D is 2D. And then basically we're just going to use our distributive property. We can't add the 6D plus the 2D. They're not like terms. So we're just going to say 1/2 the sine of 6D plus 1/2 the sine of 2D. And that's how we're going to write our answers. Number 11, we're using the sum to product formula. So this time we have the sine minus the sine. So you're going to want to look at the second set of formulas. If you have the sine minus the sine, you're going to have 2 cosine. And first of all, we're going to add them. So 3b plus b over 2. And then we have the sine of 3b minus b over 2. So when we have the sine minus the sine, you have 2 cosine of a plus b over 2, sine of a minus b over 2. So I would have 2 times the cosine. This would give me 4b over 2, which simplifies into 2b. This would be 2b over 2, which is just a b then. So I have 2 cosine of 2b, sine of b. Can't do anything else with that, so that's just going to be my answer. And the last one is going to use a sum to product one also. Down in that second group of formulas, we're going to do the cosine minus the cosine. So you want to look up your formula for cosine minus cosine. This one starts out at -2, and we're going to do the sine of a plus b over 2, so 7z plus 3z over 2. And then we have the sine of a minus b over 2, so 7z minus 3z over 2. So -2 sine, 7 plus 3 would be 10z over 2, which is 5z. And then 7z minus 3z would be 4z over 2, which is 2z. So I get -2 sine of 5z. Whoops, and I forgot to write the word sine in there. Helps if I put that in there. Sine of 2z. Now I got it written down right. So -5 times the sine of 5z times the sine of 2z would be our answer. All right, 13, 14, 15, back to proving trigonometric identities. They're adding in the double angle properties. So, a couple sets of notes you're going to want to have. First of all, your double angle identities. So if you have your double angle identities handy, sine of 2x is 2 sine of x, cosine of x. Cosine, remember we had 3 different ones depending on the problem, and if we want it in terms of cosine or sine, maybe a different one that would be better to use than another one, and then of course the tangent one. We also need all the rest of our identities, and so we have our reciprocal identities we've used before, quotient identities where we have tangent is sine over cosine, Pythagorean identities, and the odd and even ones we probably won't use on this one, but for sure those top 3 groups. Then of course we have the algebra choice that we might have to make. So you want to keep your identities handy so we can do our proof. So I always like to start with the double angle and fill in for the double angle if I can. So the cosine of 2x, since I'm trying to get this in terms of sine, I'm going to use the one that just has the sine in it. So I'm going to have my tangent of x, 1 plus, and in for my double angle then, I actually used the cosine one. I used 2 cosine squared of x minus 1. so that I could cancel out the +1 and the -1. And so I'm going to have tangent of x. I better put my my rule. Double angle. So I have tangent of x. 1 minus 1 is going to cancel out, so I have 2 cosine squared of x, and that's just algebra there. Tangent of x. For the tangent of x, I can substitute in sine over cosine. Sine of x over cosine of x times 2 cosine squared of x, and that is your quotient identity. Probably if I had written that one down first, I would have noticed that sine of 2x has both sine and cosine, and that's why I wanted to use cosine squared there, because now I can cancel out my cosines. So if I take one of them out of there, I'm going to have the sine of x times 2 cosine of x, which was just algebra, and just knowing then, if I wanted to, I don't think they even would make me do this, but I'm going to do it anyway. 2 sine of x cosine of x, again, is just algebra, and now it looks exactly like my double angle identity for sine of 2x. So again, double angle. I probably could have left out a step here or just rewritten that step as one step and just used 2 sine of x and cosine of x. That way I have less to type in. And so if I would have just combined that into the bottom one and just put algebra in there once, it would be okay also. So sometimes if you're not sure, sometimes you have to break it apart. Sometimes they'll let you put it together. Kind of just depends on how picky Alex is. Trial and error. The next one, we have 2 tangent of x over 1 plus tangent squared of x. And again, we're trying to get the sine of 2x, which we know is 2 sine of x cosine of x. And so again, I'm just going to substitute in up here for my tangent of x. Down here, if I look at that, I have the tangent squared of x, so I can probably use one of my Pythagorean identities. And if I happen to look at my Pythagorean identities, 1 plus tangent of squared of x is secant squared of x. So I'm going to just go ahead and do that. 2 tangent of x over secant squared of x using my Pythagorean identity. Then I'm going to go ahead and substitute in for my tangent of x. Tangent of x would be sine of x over cosine of x. That's my quotient identity. And some of these you can do in different orders. Secant squared I can also substitute in using a reciprocal identity. Secant squared would be 1 over the cosine squared. That's my reciprocal identity. And so now I got to do some algebra. I have to invert and multiply. So if I take this times cosine squared of x over 1, I can cancel, and I'm going to get 2 sine of x cosine of x. Just doing plain old algebra. And then you can see that we've come up with the sine of 2x, which is our double angle. And we've got them all done. And again, some of this at the beginning, I could have switched the order of how I did them. It's just a matter of what you see first and what you decide to substitute in for. One more of those. Let's see what we want to find on this one. This one we want to do the secant of 2x. So if I have to do the secant of 2x, I'm probably going to want to do 1 over the cosine of 2x so I can do my reciprocal at the end. So keeping in mind that that's the one I'm shooting for in order to end up with secant. So I've got cotangents and tangents all over the place in there. I'm going to go ahead and substitute in for all of them using my quotient identities. Cotangent is cosine over sine, tangent is sine over cosine. So this would be cosine of x over sine of x plus sine of x over cosine of x. This would be cosine of x sine of x minus sine of x, cosine of x, all of those using your quotient identities, filling in for tangent and cotangent. I'm going to go ahead and just combine those into one fraction. So using my algebra, here I'm going to take this and make this sine of x, cosine of x. So this one needs to be times the cosine, so that would be cosine squared of x. This would have to be times the sine, so sine squared of x. On the bottom, doing the same thing, putting it over sine of x, cosine of x, using my common denominator. This would be cosine squared of x minus sine squared of x. And we just did a whole bunch of algebra there. So if I invert and multiply, again doing algebra, taking this times sine of x, cosine of x, and cosine squared of x minus sine squared of x, this is going to cancel this out. So I'm going to get cosine squared of x plus sine squared of x over cosine squared of x minus sine squared of x. And again, that's just doing plain old algebra. Looking at my Pythagorean identities, if you look up your Pythagorean identities, cosine squared plus sine squared, or sine squared plus cosine squared, is equal to 1. So I can put 1 in there. I'm going to have 1 over cosine squared of x minus sine squared of x. That was using my Pythagorean. Sine squared plus cosine squared equals 1. And then if I look at my double angle identity, cosine squared minus sine squared is one of my double angle identities, which is the cosine of 2x. So I'm going to have 1 cosine of 2x using my double angle identity. And then, of course, 1 over the cosine is equal to the secant. So now I get the secant of 2x. That's my reciprocal. And so after all that work, I get down to the secant of 2x. And I have proven my identity.